So it's day 17. It's actually still day 17 from the first time me doing yesterday's work. Anyways, day 17, and we've got some pyroclastic flow. And what we've got to do here is we've got these rocks, and we've got a set of sort of buffeting winds in between them. And we've got this chamber, and our job is to essentially play Tetris with these rocks. And then after 222 rocks have stopped falling, how big is the rock? No, how tall is the tower of rocks in terms of from bottom to top? And I think this essentially, I don't know if we get to know, I guess this is 1 tall, this is 2 tall. So yeah, so we've got to do that. And there are a couple little tricks in this. So it's Tetris, so we can imagine the rocks maybe going really far down the side at a certain point. And we can't just say, okay, is the rock at the point, at the highest point? We can't do that. We're going to have to properly model it going down the sides and stuff like that. So that's kind of fine. No big deal, I think. It seems to me fairly simple, this one, not so difficult, but I've been wrong before many times. So I think I basically have as much understanding as I'm going to get of this one. One thing I'm going to change is that I'm going to give myself, essentially what I noticed is that my planning process is currently a bit hampered by not being able to sort of plan after modeling the problem using code. So what I would like to do here is to come up with a working model and then fire some stuff at it and see what it does, and then plan out how to get the kind of algorithm working. So I'm going to give myself 1 pause. So what this means is that at a certain point, I'll be able to pause the timer and then go back to the planning and try using the code I've written so far to plan out, sort of see what happens in certain situations. So I'm going to try that out. I think it's probably the right way to do it, even if it's always feel a little bit sneaky doing these things, but in terms of solving the problem, it is the right way to go. And probably the quickest way to move ahead. So I've done a little bit of planning here. I've got an idea as to what needs to be done. Find the highest rock, add the next rock in sequence 3 units above, move the rock left or right based on the sequence, do nothing if it would overlap with a board boundary or another rock, move the rock down, and then if the rock is it cannot move down, it's settled and it's sort of done. It's not moving any further after that. And I think rather than go through and check every rock for overlaps, let's add, when a rock is settled, let's add its coordinates to a set of cells that are sort of blocked. They're kind of done. And then we can just nicely check kind of overlaps just by going through the cells in the rock and after it's moved and seeing if it overlaps with anything in the current set of settled cells, if that's not too much of a tongue twister. So I've got a few decisions still as to how to model the state and how to work out the kind of overlapping. So let me figure those out. So in terms of functions, let's say I've got find height of after in rocks. And to do that, I'm going to need to find highest rock, highest point, add rock. And for this, we'll need to get next rock in sequence. Then we, until now, or it'd be like looping forever. Get buff fit, get next buffet, apply buffet. So probably we can get these, and then we can apply gravity. Is if so for this we want to essentially get like try like is rock position valid? And then if it's not, so we kind of got this sort of thing. Okay, and then really we've got okay, and if it's not valid, settle the rock and add it to whatever state we've got. So we kind of got this sort of process. And for this, we're going to need some state. So let's model out the state. We want to get, let's say, the buffets, which will be a list of, I don't know, let's call them strings. Or I think we can probably model it like that. We've got rocks, which will be a list of rocks. We've got active rock, maybe like current rock, which will be a rock, and it'll have a position, I think. Current rock position. And we've got settled rocks and locked cells, which will be a set of tuples of int and int. And this will be a list of rocks. I think we'll just have rock know its own position, and then this can be a kind of rock template. I think we'll just, yeah, I think that's unnecessary. Okay. Okay. Do we need anything more? I don't think that we do. I think it's fine. Okay, in which case we want to come up with a rock. So a rock will have a shape. How we model the shape. I think it'll be a list of ints, and the int will be a kind of 1-0 kind of affair. Because it could be a boolean. Anyway, I'll keep it an int just in case step 2 makes things hard for us. Or we could just say it's got some relative coordinates. Actually, that would be better. That's more how I'm doing it elsewhere. Then, and it's also, so this is going to have a viz method. I think it could have a is rock position valid given a rock. It can have a settle rock method, I think. I think it can have a get next rock in sequence, and it can have a get next buffet. And then I think all the others will live outside of it. Okay, so this will have a shape. It will have a coordinate, which will be a tuple of ints, tuple. I never know. It should have a translate with a set of coordinates, and it should have a does it need anything else? Maybe like chords from would be kind of nice. That would be nice to get. And I think because we're not going to create loads of rocks, we can probably no, we could probably copy them when we need them. Let's not copy explicitly and ruin our own lives with memory consumption. Okay, so I think this seems pretty reasonable. So the first thing I'm going to do is I'm going to write this. I'm going to write rock. I'm going to write state. I'm going to write a visualizer, and then I'm going to write the main loop. Right, the sort of movement. Right add rock. Right step rock. And then I'm going to probably replan at that point. And this actually could have find highest point, or rather we could have highest point being starting at 0, and then it could get updated whenever a rock is settled. That would work. Okay, should be pretty fun. Let's get started, I think. Don't need this window. Okay, VS Code. I think I just heard a creepy laugh. Anyway. All right. Should we get going? Okay. Then I'll begin. I've also made a new timer, so that'll be handy. Okay. So I'm in the wrong directory. I'm actually going to reset because I don't need this stuff being in my timer. This is just me setting up. One. Don't want to go back to day 17, that's for sure. Okay. Let me reset again. Okay. So this should be 3 and 4. Okay. Okay. I think we're still running. Okay. Fine. Okay. Gee, I don't think I need that. Yeah, so we can do this. That's what we want, actually. Yeah, that's right. Okay. So that actually shouldn't have a default. This kind of shouldn't either. Should be none. Okay. Can't stop thinking about Warren Buffett. Okay. I think I'm going to check get next rock first. This is going to have let's start building the trial state. I think that's fine. And rocks. Now rocks is tricky because it should have this can be a default field default factory. Actually, I think these are immutable, so it's fine. Yeah, great. Okay, so the rocks that we've got, such as they are, look like this. So we've got actually kind of annoying. So we're going to have zero, zero, xy, 1, 2, 3. That's rock 1. 2 is going to be not 0, 0, x, y, 1. No. This one and then y1 with x0, 1, 2, and then it's going to be 1 and 2, 0, 1, 2. Yeah, great. Okay, so that's that one. This one's going to be 2 across on the 0, 2 across on the 1, and then 0 across on the 2, 1 across on the 2, and then 2 across on the 2. This one's going to be 0, 0, 0, 1, 0, 2, 0, 3. That's it. And then this one is going to be 0, 1, 0, 0, 0, 1, 1, 0, 1, 0, 1, 1, 1. Those are the rocks. Okay. And so the next rock in this rock should be state rocks 0. Okay. That's how you do that. Yeah, I don't think this is erroring anymore. Okay. Great. So to get the next rock, we're going to keep we're going to do the same there. Okay, so get next rock is rock equals self rocks next rock index. Okay. One, two, three, four. What, 0, actually. So it hasn't looped around. Okay. Great. All right, now let's do the same in the buffet. Great. Okay. Right. Okay, so let's check, is rock position valid? So at this point, actually settle the rock. Let's settle the rock. So let's say we want to settle a rock and we want to settle wait, can I not? That's irritating. Okay. Fine. Okay. So I'm going to take this, I'm going to set its, going to translate it by 1 and 1, and then I'm going to settle it. Now at this point, the highest point should be I was just thinking we're going to need to keep going up, but I don't think it matters. We can use negative coordinates. Possible famous last words. So the highest point I think will be 1, 1 now. Let's make it -10 and -10. And we'll have it be, then it'll be -10 and -10. The trial state settled rocks. What is it called? Blocked cells. Should be -10, -10, -9, -10. Okay. So the highest point actually should be -10 now. That's actually the minimum. Okay. Oh, yeah, okay. 7, 8, 9, 10. So they're in a weird order. Why are they in a weird order? Oh, it doesn't matter, I suppose. They're a set, is why. Okay, good. We're making good progress. Do we have all these implemented? No, we don't have is rock position valid. Check. Trial state is rock position valid, and we want to have another rock. And we want to have this be -9, so this should now be valid. Whereas this one should not be valid. I'm going to make this a little bit tricky by having it just overlap by 1. Which I think so if this was 4 cells, okay, let's have this be 13. So it would be 13, 12, 11, 10. So it overlap by 1. Okay. Okay, great. So 4 point in rock points. Locked point in block self-locked cells. Return false. Return true otherwise. Okay, we're in a good place. So that's the rock, that's the visualizer. I haven't written the visualizer actually. We're going to write add rock and step rock next, but I'm going to write the visualizer first. And I'm going to use a new thing that I wrote. Okay, for y in range let's say highest point to 0, going down by -1. And we're going to have 0, let's say range -1 to 8, going up. Okay, and this cell is going to be, so if blocked cells all that, append this, else row append this, in rock self current rock points, then append red else row append dot. Okay, let's see if this actually works. So this is not working. Actually, that is going the right way. Okay. All right, that's not doing anything exciting. there's nothing there. Okay, so where are we going? We're going from -1, 10, 0, 10, 1, 10. Let's have the x be 3. And then this can be 6. Kind of, it's probably still works. No, it doesn't. 3, 4, 5, 6. Great. Okay, so we're getting something working. Those are the blocked ones. Fine. Great. That's the test state. Great. Okay. We're not going to make this a gold run. It might not even be silver, but let's see how it goes. Okay. Add rock. State. Okay. And we're going to put this at so what does it have to be? They start off, left edge is 2 units away from the left wall. So I think we'll call that 2. So the left wall will be 0. And its bottom edge is 3 units above. That's 3. Okay, fine. Great. Now it's where it should be, actually. I think that's it for that. So let me make this the trial state. Then let's start adding rocks. Okay, so the highest point is 0. That makes sense. So actually we want to go probably from the rocks Start Y should be for self current rock. Board 1. Okay, so that goes from 3. Great. And I think we're at the right point. Let's actually just check this. Okay. Great. Okay, so we're getting somewhere. Now, step block. So while true, I buffet. Apply gravity. If result, if apply gravity is false, then state current rock, state settle rock. Okay, settle the rock. Fine. And we actually don't want to loop forever here. This is just one step. Okay, apply buffet. Okay, and I'm going to apply gravity first. And I'm actually going to have this be a window, I think, from -3, -3. There we go. Great, so we'll keep that going. And we're going to apply gravity, which will involve moving the current rock by 0 and -1, actually. Okay, that pushes it down. And we're going to have So we'll actually do this, and then we'll translate it. And then we will check, is rock position valid? If so, we will translate it properly and return true. Otherwise, we'll return false. Okay, so the problem is at the moment, rock position, we need to check if point if point x, point 0 is greater than 8, if point is less than 0, I think if this is greater than 7 should be return false. And if point y is less than or less than 0, it should be false. No, greater than 0 with y. Okay, let's put some logging in here. Okay, let's try moving it down some more. Great. Now for the buffeting. Then the trial rock should be translated, or essentially the so this one should move us to the right. Otherwise, it should move us to the left. We should translate this by the buffet. And then if the rock position is valid, we will move rock buffet text. Translate it. return true. True, otherwise return false. Okay. Great. That works. Okay. Add rock while step rock. Let's say have this return settled. Okay, step rock. State if result equals settled. Add a rock. Okay. And then let's get this going. Okay. All right. Let me just check how correct this is. It's wrong in several ways. Okay, let me okay, I'm going to take my pause here. Okay, let me try this again. So 1, 2, 3, and then this one just randomly appears. Just right where it is. When it should appear. Okay, let me just check this first one as well. Okay, to the right and down, to the right and down. to the right and down. Okay, and again. Okay. So it begins right and down. Okay, so that's wrong. It should, I'm not going to write any new code here, but I will just adjust some constants. So this one, does this count? Well, let me just, we have that. And I also want to have another viz right at the start as well. Okay, so that's the start position. To the right and down. Right and down does nothing. Right and down does nothing. Then left and down and settled. This one arrives at the wrong place. It arrives at, so the x coordinate's right, the highest point. Oh, wait, I know what it is. Okay, each rock appears so that its left edge is 2 units away from the left wall. And its bottom edge is 3 units above the highest rock in the room. Okay, so it's bottom edge, not its top edge. So actually we kind of want this to be kind of want this to have like an offset of some kind, or just like take the lowest. So its left edge is fine, its bottom edge is the problem. So one of the things we'll need to do is, just going to plan in here. Translate the points by the height. Shape. Okay, so I need to do that. Now what I'm sort of curious to see, can we kind of, yeah, okay, so it should end up 2 points to the right of it and 3 points to the left. Let's see if we can just piece together the left edge from getting it to do all this stuff. Sort of weird why they're arriving to the so far to the right, isn't it? And we add a rock. We say the x is 2 always, which is right, isn't it? What I don't get is why that's being added there. I think I'll start printing out the rock again. This one's the weird one. So this one ends up at 5 very quickly. I'm not copying here. That's why. Okay. Love to see something bounce off the left. Kind of weird that we didn't buff it anywhere there. maybe not that weird. Anyway, I think this is as much as I'm going to learn without doing some more coding. Let's resume. Okay, so here we actually want to translate by the height which will be the max y coordinate. So for a particular shape, it would be that'll be the height, I think. So I think that's that. Or not. I don't think I need these checks anymore. Come on. No time for this. Okay, now is that right? No, it's not. But is the sequence right? Okay. Does it arrive at that point with 3 between it? No, it arrives with 1 between it. And its height is 3, so I think this needs to be... Let me work out what it thinks the height is. Thinks the height is 1. So it's actually +1. I don't need those brackets. Oh, okay. That's not right. That's too far to the right now. All right. Let's try closing this in a little bit. No, that's not it. This needs to be that. Yeah, great. Is that where it's supposed to be? Oh, okay, great. Nice. All right. Does it end up there? Yes, it does. Perfect. Okay, we're getting somewhere. Now, what's my other to-do? Yeah, I need to copy this. I'm going to let this run for a bit. Okay, this starts to look kind of along the right lines. Okay. Let me try that again. That bit wasn't quite right, I think. Yeah, so I think the bumping on the right, on the left is maybe wrong. Let's go back to the input. Okay. And actually, I'm just going to viz whenever a rock is added now. Okay. That one ends up there. This one ends up. Wait a minute. That's not right. Okay. That ends up there. Yeah. This. We're missing a shape. We're missing a shape. That's what's going on here. Zero, 1, 2, 3, 4. Zero, 1, 2, 3, 4. Ah, I'm missing a shape. I'm missing a shape. Yeah, there we go. That's right again. That's right again. That's right. Is that one right? Yes, it is. Okay. That's not right. Maybe I'm getting the buffets wrong as well. Yeah, I surely am. Okay. Yeah, that's perfect. That's perfect. Great. Now, we want to, running out of time here, we want to now go through the number of rocks that have been added. So we're going to keep track of that. Okay. Wanted to print the rocks added and as point as well. Okay, and I don't want it to do this anymore. Does it really have to be this slow? Wow, that is slow. Didn't expect that. What's making it so slow? Oh, the sleeps, obviously. Idiot. Okay. 223, 3068. Okay, great. Now we only have a short amount of time to get the real input. Okay. So the real state is this. And we've got this horrendous thing. That'll do. Why am I not getting the right thing? Have I done wrong? Huh? Oh, that's, come on. Oh, just state, come on. $3,081. Okay. This is probably got to be right or not at all. Ah, nice. Okay, that's bronze then. Lovely. So part 2 involves essentially us simulating further. It's enough numbers that you can't really iterate through all of them in a reasonable amount of time. I've got a somewhat powerful computer here, and I didn't even break a dent in just looping over this amount of iterations. So it's the classic advent of code. Just do it a billion more times now and try and make it efficient. So we're going to need to rethink. And to help us rethink, here is the video of that I made of this happening. So here let's take a look at this. I'm gonna just do a little bit of window management here. Oh gosh, okay, that did not work. Okay, so one moment. Okay, so here's a recording. I've got it on half speed, so let me try and see if I can slow it down even more actually. So you can see that one thing that opens up as an opportunity is if we could ascertain when a kind of blockage has happened, we're going to know that we don't need to model anything beneath that. So that might help, but it's still not really going to get us as far as we need to go, even if we were to kind of segment it in that way. We could try to have a go at seeing if there's any pattern in the height as it changes. That might be interesting. We could sort of graph it out. I think I like that idea, actually. Yeah. Yeah, so if we generate, let's say, the first, well, this amount, in theory, if there's a pattern here, right, we should be able to spot it in those numbers. And we can probably spreadsheet it out. So I'm going to use my part one, I think, to generate a list. And I'm going to count this as kind of planning time. A bit mesmerizing, isn't it? So if we can kind of spot any patterns there, that'll be an interesting thing to look at. So I'm going to reshare. I'm going to share my VS Code. And I'm going to print out. Actually, I'm going to print out before every rock is added. I'm going to print out the state. What do we call it? Oh, come on. The state highest point. Come on. State highest point, and I'm going to make it a CSV. So it's going to be a state current rock. No, state highest point. And this is going to be state rocks added. Okay, and we don't want any other prints in here. So we don't want that. Actually, I'm just going to have this. I'm going to okay, and then let's have this go to so I might go there. We'll give that a moment. Okay. So we've now got this, and it's a little bit noisy, isn't it? But if we shift over we open up a Google Sheets. think this is small enough to copy paste in. Nope, it's not. Edit, paste. Whatever. Didn't help at all. File, import. I can never remember how to import data. Okay, upload. Sorry, you'll get to see this in a moment. Okay. Let me just sort this out, and then I'll share this. And so we've got the top here, we've got rocks added, right. So, and then we can extrapolate what the rock type is and the buffet as well. Probably should have done that already. Actually, no, this is with the SAM. I'd want to do it with the trial data. That's what I want to do. Sorry, let me do this again. So let me get this. This be the trial state, and I'm going to print out the buffet as well. So that was the last rock. And this was the last buffet. No, actually, because there's multiple buffets per thing, isn't there? But we could probably say that, well, if we need the buffet information, then we can get it. It may be relevant. No, I actually don't need that's not really useful. Okay. Just get the first 10, just to make sure it's not obviously wrong. Oh, very irritating. Okay. Okay, great. That was the one before, right? But it doesn't matter anyway. Okay. I All right, let's try that again. Great. Okay, back to the sheet. So I'm kind of interested in plotting these two on a chart. Well, that's pretty linear. It's pretty linear. Okay. Well, I mean, we can get close, certainly, right? So the question is, what leads to the differences? Wonder if we can get it to give it a formula. One 1.51x plus 5.27. Okay. Right. So this times 1.15. Does it stay broadly in line? No, it doesn't. Kind of separates. I don't know what a factor is, if I'm honest. Okay, I've got to log in for some reason. Now that is weird. Is the data just too big? Now what is this then? $1.51. Oh, right, so it's the other way around. Sorry. Very silly. Which would mean to go the other way, you would end up multiplying by 0.75. No, I'm confused. So if we want to go from, that one's right. This one's roughly right. This one's roughly right. Yeah, so that the error does the error stay? Can we get the error to stay constant? Are there any places where the error is 0 even? could find that out. At 2000, it's this. Does this appear anywhere else? In 525 there. 52 here. 52 here. Five 175 here. So there's some interesting kind of things to note. It seems like we're sort of getting to, it will be very interesting to know, for example, like if we get some of these kind of interesting numbers, do they repeat? So 1.52, do we end up getting 1.52 anywhere? I have a feeling this is tending towards something, maybe. 3, 2, 1, and then at some point, maybe it'll get even lower. And then if we could find a point where it's completely flat, I wonder whether there are any points like that where everything goes completely flat. Is that possible in this? Yes, technically, yes, it is. I wonder if they repeat. What's going on at 0.2000, I wonder? We can look at this because I've exported all the images. Wow, did I really go beyond? I didn't mean to do that. Oh, no, wait, it makes sense when we're exporting multiple. Does it ever repeat? I'm kind of curious if it ever repeats. Okay, I think maybe there are some repeats. In principle, if there were repeats in terms of the surface structure, and we could predict when these were, in a sense, this is cyclical, right? This is cyclical. The behavior of the blocks is cyclical. behavior of the buffeting is cyclical. And if we knew how big the input was and the blocks were, and we could look at that point, then in theory, we could possibly hope potentially that we ended up at a nice point. Let's try and find it. Okay. If state next buffer index is 0 and state next rock index is 0, okay, so that didn't take long. So when 14 rocks are added, for example, oh no, actually, I realize I've gotten this slightly wrong. These screens are not about the, yeah, okay. Let me actually have one. Let me actually make box grid frame. Yeah, and then if we start this one off at 1, or actually, yeah, that's right. Yeah, great. That would work. In terms of fizzing, get rid of all these. And we'll only viz just before adding a rock. Okay, so we're looking for moments where maybe the top is full. Let me get rid of this. Let's generate the whole thing again. Great. Okay, and then let's look at, so this would be rock 1. And at rock 1, sorry, I'm just looking at the spreadsheet. Just close this off so you can see the screen. After rock 1, the height is 1. Yeah, so, and then it kind of goes down. And in principle, there are only 14 different buffets. So we should be interested in with the trial state, right? Yeah. We should be interested in 14s. 14s. And every multiple of 14. $28. 42. Let me actually. What was the big one that was super interesting down here? It was 2000. What's at 2000? Nothing interesting. Um, 140, 1400 maybe. Good look there. In principle, we could still make everything work if we could predict the surface topology at a particular point. Like if that was possible, then you know that might be quite interesting. Anyway, so I'm gonna just so good if I could find a flat surface. Is it even possible? Yeah, it's definitely possible. And then if it was predictable. I know, I mean, I can just look through this, can't I? How do you go back and forth a frame? Whoa, okay, not what I wanted. I love that VLC as a boss key still. Is there just no previous frame? That would be so irritating. No, there isn't. Okay, fine. Well, if it's there, it's not obvious, is it? But it's possible. This is definitely exceedingly dull, isn't it? Okay, great. You just can't pause anymore. Fine. Okay, VLC is upset now. All right. So if there was a way we could see whether there was a flat surface at the top, then that would help us out. We could sort of use the visualization to show us this. This logic would kind of be interesting to try. Okay. I think I'm probably going to write some code now. So that means I'm going to need to use my pause if I want to pick it back up again. So, but I think that's probably the right thing to do. Before I do that, let me just think this through. In theory, let's just look at this data a bit more. So that, I mean, it's one idea that potentially if we found a flat surface or a predictable surface that was cyclical, then we could use that. So there's that. If we can't, is there any? We know that the first 14 are this. I can't remember this is the input or my trial data. No. We know it's very linear. We know that with this formula, which we can calculate, I think, forecast, what is it actually? This, okay, the data Y is the B to B. Data X is A to A. It's going to be about this. It's going to be around that. And if I was forecasting some data that I actually had, like the 2022, I would end up with this number, which is 3067, and it's 3068. That's pretty close. I wonder if this is actually really close. What is the and then let's pull this across. I need this here. So it stays reasonably close, actually, like within one. Which means we could we might get lucky. It wouldn't be very satisfying though, would it, to get lucky? Am I okay getting lucky on this? I think it would be interesting. I think it would be funny. So this one is Is there anywhere where it's bang on? No, and I don't think it would help us if it was. So, but in theory, it should be that or around that. I think this is exactly the right answer, isn't it? So, oh, actually, it's quite far off. If this is the trial data, which I think it is, let me just double check. Okay, so heights 1, 4, 6, 7, 9, 10, 13, 15, 17, 17, 18, 21, 23, 25, 23s, just two 23s. So for 682, for example, it's 1036. Okay, fine. So this is the right data, and it's nowhere near what it actually is. Or it's like quite near. It's like somewhat near, but it deviates quite a bit by, more than we could ever hope to actually manage. So I guess these errors multiply up in the end. But it's within, I guess, kind of 6 significant figures, which is probably about right. Yeah, it would make sense that would be well within. But it's not perfect. Okay. I'm definitely getting a little hungry now, so I'm gonna have some dinner. And I'll keep thinking about this. I've had an idea. Let me try and play this. So we can see this go, and if we're interested in patterns so that we can project forwards, then a simple way to look for these patterns would be to serialize, let's say, the last kind of 20, 40, 50, however many rows, and output it to a file. And then we can see if the same sort of segment appears repeatedly on a repeated basis. And that would allow us to spot maybe what the period of these patterns were, and then kind of the veracity of them. So I went ahead and did this. I output based on part 1. Just instead of this being visual, I just put it out in text. And so, open this up. So we've got like each of these lines is like a kind of last n rows. I can't remember how many rows actually. It's 50 rows or so. And so let's kind of like pick one from the middle. And just, we can see that it does repeat. And also what you can see in addition is that this bit here, we can only see partly of, and this bit here, it's constant. And what this indicates is that we're seeing a repeated sequence, not just an individual repeat. And this seems to be kind of like, okay, 44, 79, 14, 49, 84. It looks promising, but there's actually an even easier way. And so I went back and I looked at not spoiler this for you, but I looked at one moment. So let me actually share this so you can get a sense of what we're looking at. So we've got the rocks added and the height here, right? So we can see the height go up, of course. We can see there's a pretty close correlation. And what I've done here is I've worked out how much was added between each one. So here there were 3 added between 4 and 1, 2, 4 and 6, 1, 4, 6 and 7. And then I copied this into a text editor. And we can see it all here. It's the same data. So let's try and see if we can spot any patterns in here in the amount that the height is going up. So let's just take a chunk and then Command D, and then we'll get to the next repeated version. You can see they're very evenly spaced, these repeats. And you can see, you can't even see these numbers changing because that's a constant pattern. This is a very good sign for us. And so the final bit to look at is, what's the interval? So we've got 40 here, 75. So let's go from 74 to 40. Now, if we repeat this, you'll see there's no gap. So this is a repeating pattern. The height goes up by 1, 2, 3, etc., etc. Gets back to 1, 3, 3, 4, and it's 1, 2, 3, 0, 1, and it just repeats. This is very good. Now, it's not at the start. The start is different. It takes a while to get itself into this jig. But once it's gotten into it, it's consistent. So going back to the spreadsheet for a moment, if I scroll all the way down here, we can see the pattern here. So let's take this, put it up here, and let's actually put it at the first moment this pattern appears, which I think is around here. So actually, let me put it here, and then I'll just find it. So the first one it appears for, I think, is 34. So here, actually, 35. 1, 2, no, that's not right. 1, 2, let me find this pattern properly. Okay, it starts at, yeah, 34 in my file. So it's 0, 1, 2, 1, 2, 0, 1. Yeah, great. Okay, so this one is 35. So let's have this here. Great. Let's move this up to here. Okay, so now we should be able to calculate. from the, let me freeze this, from the rocks added, so this is getting kind of similar to code here. From the rocks added, minus 35 plus 60. So it starts at height 60 plus this number. Okay. Yeah, great. And then if we keep this, if we actually make a, I think a lookup or something here. So 1, 2, 3, let's have this be 0, 1, 2, 3. Great. And then we can set this plus 1 times 60 plus VLOOKUP A36 modulo, well, I guess the length of the pattern, which is 34, 35 maybe. With the range being K36 through L70, and the index being 1, I think. Yeah, I need to, no such operator here. Okay. Yeah, so this has got to be, yeah, divided by 35, I think. I think we could have this, actually. Yeah, great. So it's 60 plus, okay, so 61. That's right. Let's get some conditional formatting on this. Okay. That's not quite right. Yeah, that's what I want. Yeah, and actually we want to kind of, Great. Okay. So that's 0. This one is going to be 0. Oh, I forgot to floor. Oh, and I forgot several other things. Yeah. Okay. That one's actually 2. Has it actually should be 3? Yeah. Okay. Getting there. Still 2 for some reason. Oh, I know why. Come on. Guess this is why people don't use this thing that often. What? Oh. Still not quite there. Oh, no, wait. It's not. Yeah, A38. So this one's 2, which means we should be looking up with I don't know what VLOOKUP does. First column of the range for a key and returns the specified cell in the row found. Oh, first column. Okay, 3, maybe? Yeah, there we go. Now we're getting there. Great. So this one then. This one is at 113, and this one. This one in total adds 53. That's wrong. Seven, maybe? +1. Okay. No, not quite. Okay, this is just silly now. I know how to do it. I'm just sort of dilly-dallying in Excel now. The so what's this then? 2. So that's 2. 2 times 53. We pull this down. And then this one, I'm going to get this to work, I think. So this one at this point should be 2, but it's not, it's 1. And it shouldn't be multiplying. It should be taking 53. Okay, there we go. This one's now 2. 2 times 53 is 106. This one's coming out as 1. It's quite a big jump, isn't it? So this one's coming out to be 53. And now this one's coming out to be 106. Okay, let me take that off. Okay, great. Now we go. Here we go. Great. Okay, so now we've got our formula. Now we just need to put it in our real number. And instead of A36, it should be this number. Okay. That's the same. That's the same as it should be. Brilliant. Okay. So in which case, now what we need to do is look for the cycles in our real data, and we'll be in a brilliant place. So let me share back the VS Code. And I think I'm going to post-rationalize the time on this, I think. So let's have this. I don't think we need to go any further than that. Actually, don't want that. Okay. Right, let's copy paste this. Switch over to Google Sheets. That's annoying. Okay, let me swap that over. I don't know what you're doing now. Okay, perfect. So now let's take the height, stick it in here, and we'll look for some nice repeats. Or actually, additions rather. So the additions should be B2 minus B3. Okay, fine. All right. Now, I do hope we find them. Maybe they're further out. Could be. The input's a lot longer. Yeah, that would make sense. Okay, let's try going a little further. And all I actually need is sort of actually this data. Let me try this and just see the data. If I don't mess that up. Okay. Now let's find it. There's too many, maybe. What was it? Heights. Okay. I headed to the middle. Ooh, interesting. No, that's not right. Yeah, that data isn't right. Yeah. That's why. And yet still clearly wrong. Okay, fine. All right. Okay, so it's a long period. In this case, we're going from 4643. No, 4643 to 3638. 4643, 3638. 4643. 4643. Are there any non-selected cells here? Yep, that's good. That's good. And was this also part? Yes. About this? Yes. That's repeated. Okay. That's repeated. That's not quite. So we're getting closer. Fine. All right. So so the way to look for this is, can we find the further back bit? No, so we're pretty close. Yeah, okay. All right, let's try this. No, so it starts here. So this is the beginning. Let me copy this somewhere else. And it's quite long. It's quite long. Then after this, it goes cyclical from 533 all the way to 533. Okay, 533. Okay, so we got that. That's the cycle, which is very long. 1726. That makes sense. So that is enough information to construct the full sequence. So let me switch to Google Sheets, because I think we should keep with Google Sheets. Bit of a novelty, isn't it? And let's take a look at this. So a good formula, let's define this as a named range. And this is a cycle. Great. Okay. And this, so it's if, let me I'll just turn my video off. Okay, so it will be if n is less than 533, 532, and index in I don't even know what n is. Anyway, weird. But actually we want to have A2 in here. And let's have a bit of conditional formatting. Oops, wrong one. Okay, great. Now, if it's over, we want to get the amount that it's over by. We want to get A2 minus 532. And this will be a good one to start with. Cycle. This should get us as far as yeah, great. That gets us that far. And then we want to modulo on the length of the cycle, which is 1725. Okay, perfect. That's, oh, did I miss one there? Yeah, we did. Why is this wrong? Oh, so it needs to be +1, maybe? No. The 0th index. So we can't have 0 indexes, which will be annoying, but it may not be a problem. So now we just have to sum up a very large range of numbers, which is not what we wanted. So actually, we kind of need the real numbers. Okay, fine. Let me generate those. Generate the first, however many, 7235. Okay, that's enough. Oh, multiplied by -1. Yeah. Okay, let's add in the heights. Okay. So for this, we actually want to, how irritating. Okay. Okay, and then the same deal here. Okay. So that's all good. And then this one will need to be don't need any of this. Okay, so we get this far and then it goes wrong. Simple. 0, just so irritating. Okay, so what is index Okay, so number 1 is 3. Fine. Five, 3, 2. Let's go there. 5, 3, 2. Mod 0. That's 0. I don't even know how this is working. What is this number? 0. What's mod? Oh, I get it. It's, yeah, okay, fine. I get it. I get it. I get it. I get it. Because it doesn't kick in until that point. Okay, anyway. So if this was 5, 3, 1, we'd get the error. And at this point, we'd need to plus 1 to this and have it be cycle C. Yeah, and have it be 800 plus. Don't tell me the last one's a 0. Oh, no, wait. 797. Yeah, okay. All right, all right. It'd be great if I didn't keep losing my place in these absolutely critical. Five, 3. Yes, that's the formula. And it's slightly wrong. Three. So this is 3, which is right. Three. Three, 2, 0, 1, 2, 2. Okay, so there's one. It's one offset. Fine. Okay, so I just need to start one later. Fine. It's fine. It's fine. It's fine. Don't worry about it. Then this one can start from 800. Not quite, but we're closer. Okay. I don't know why I'm doing it in this silly way. Okay, let's go down to where it fails. Yep, so here it just jumps back. So this should never be 0 for 1. So we can say that whatever's going on up here, it's going to have to be 1. Which means the first one should be 320. Is that right? 320. Okay, right. So we need to go up even one more. So actually we're missing an item, which is this 3 here. There we go. Okay, this gets us better. Okay. So this one at this point, 1274. What does this actually come out to? Fine. And then this one, 0. Okay, so at this point we need to add in the full amount of full total, which is 2630. That should be 1. Great. What is it again? Two, 630. That's right. Okay, that's right then. In which case, formula at the end should be the one at the start. Great. And so now we want to get our magic number in. And the outcome is this formula, but instead of A6, G5. This number. What do you think? Do you think we'll be there? That's right. Okay. Well, that was needlessly involved, but I don't know. I'll give it some sort of time, probably an honest time, based on this is basically programming one way or another, even though I did sort of do it very slowly. Yeah, that's that. Up to date.